Hello my dear children, today's topic is free radical substitution reaction. We've already started substitution reaction and done with the nucleophilic substitution, electrophilic substitution. Now this last type of substitution, that is a free radical substitution. The first question is, what is a free radical? Free radical is an intermediate, that is a reactant and product between. It is an intermediate and it is one of the very reactive intermediate. There are four intermediate you must have listened: carbocation, carbanion, carbene, and this is the fourth free radical. Why it's a very reactive reactive intermediate? Because it has an odd electron. It has an odd electron, and how it is formed? By homolytic cleavage. I'm going to show that I have the halogen X2 and this is my 2 electron in a bond, and this is a homolytic cleavage takes place in the presence of sunlight. Each electron shifted to individual atoms. It led to the formation of free radical. So this is free radical formation, that is by homolytic cleavage. Now dear children, free radical substitution reactions always takes place in the 3 steps, and the name of those steps are, I'm taking one by one. That is, first, this step is a chain initiating step. It is a chain initiating step. So these reactions takes place in 3 steps. Where there is a free radical formation, the reaction is endo. Always remember, chain initiating step is a endothermic reaction, and here the free radical formed on the product side. Free radical is on the product side. This is chain initiating step. Formation of free radical is in the chain initiating step. The second is chain propagating step, which is the exo reaction as well as endo. There are 2 steps. One is exo and other is endo, and here you will see the free radical is on both sides, that is in the reactant side as well as the free radical is present on the product side. You will see sooner. Now I'm taking methane. I'm taking halogenation of alkane is my mechanism. Free radical substitution action, halogenation of alkane. I'm taking halogenation. This is methane, CH4, methane plus halogen free radical, first step formation. Now this is any one of the bond you may break like homolytic cleavage, and this form H radical and X radical, forming HX molecule. H radical and X radical is HX molecule, and you left with CH3. So it's a CH3 radical. Now you can see free radical is on both sides, on the reactant side as well as on the product side. This is the first step of the chain propagating. Exo it is. Next is CH3 radical plus, now there is a, that is plus, it is your halogen is coming now, second molecule, halogen. Now you can see here it is again homolytic cleavage. Your answer is a product. It is, the product is CH3 radical and radical bond. This is your product formation plus X radical. So dear children, you might have seen the free radical is on the reactant side as well as on the product side. The reaction, one of the reaction is endo and the other reaction is exo, where there is a formation of the product, and your product is CH3X. The third step is a chain terminating step. Chain terminating step is an exothermic step. It's exothermic reaction, chain terminating step. So here the free radical is only on the reactant side, right on? Free reaction is exo and the free radical is on the reactant side. So this is chain initiating, chain propagating, and last is chain terminating. All the radicals, whatever the left radicals combine, X radical arrow X2, CH3 radical plus X radical arrow CH3X. CH3X. The third is your CH3 radical plus CH3 radical arrow C2H6. So this is a exothermic reaction because of the formation of the molecules like a halogen, methane, new bond formation, you may say. So dear children, this is your free radical substitution reaction mechanism, and it is best shown by halogenation of alkane, nitration of alkane, sulfonation of alkane. Now write down types of free radical and stability order. benzylic C6H5 CH2 radical. It is a benzylic. Benzylic free radical is the most stable radical because of the more resonance structure than allylic CH2 single bond CH double bond CH2. You know what is an allylic carbon? Next carbon to the double bond is an allylic carbon. So it's a allylic, more stable. Then tertiary CH3 C CH3 CH3. It's a tertiary free radical. After that there is a secondary. I'm writing here CH3 C CH3 H. So it is your secondary. Next is CH3 C H H primary, and the next is CH3. It's the stability order: tertiary, secondary, and primary. So this is types of free radical along with the stability as well as mechanism. And after that we write chlorination. Halogenation is chlorination, bromination. The first topic is halogenation of alkane. You know, there are the halogenation is chlorination that I've shown to you. If you will do chlorination of methane, it forming 4 products: CH3Cl, CH2, Cl2, CHCl3, and CCl4. So chlorination and the bromination is same. Fluorination is avoided. Chlorination and bromination is easy. So direct halogenation, direct chlorination, direct bromination is possible. Fluorination is explosive action, it should be avoided. Fluorination. But the iodination is reversible. If you do iodination, the reaction is reversible. It led to the formation of CH3I and HI, but the problem is reaction is reversible. To make the reaction irreversible, the reaction must carried in the presence of some oxidizer like HiO3, HiO4, concentrated nitric acid. This oxidizing agent oxidizes Hi to iodine and prevent the reversibility. Chlorination and bromination is very easy, but fluorination should be avoided. The reaction is explosive. Iodination is reversible, so make the reaction irreversible. The reaction must carried in the presence of concentrated nitric acid. So this is halogenation of your methane. I have taken methane. Now if you want to do halogenation of toluene, I am taking toluene halogenations in the presence of sunlight and the presence of FeCl3. Very important question it is. In the presence of sunlight, it is a free radical substitution. In the presence of FeCl3, is the electrophilic substitution actions. So your electrophil, it is toluene and halogen, that is halogen, or you may call it chlorine. It's a chlorine, ortho and para directing. So it's a 2-chlorotoluene and 4-chlorotoluene, or ortho-chlorotoluene and para-chlorotoluene. So this is your, in the presence of FeCl3, it is an electrophilic substitution reaction. But in the presence of sunlight, the reaction is a free radical, so forming the CH2. So it is CH2Cl. It's a benzyl chloride. It's a benzyl chloride. So always remember, in the presence of sunlight, the halogen gets substituted at aliphatic carbon, but in the presence of FeCl3, the reaction, that is halogen, gets substituted at aromatic carbon. So this is your chlorination of toluene in the presence of sunlight and in the presence of FeCl3. Type of the reaction is different. One is free radical substitution and there is electrophilic substitution action. Now I am taking chlorination of ethyl benzene. CH2, CH3. It's the ethyl benzene. If chlorination of ethyl benzene, there are products possible too. So it's either the substitution can take place here, CH, Cl, CH3. So or the substitution takes place at primary carbon. Now it is your CH2, CH2, Cl. Now these are the 2 products possible. So we will prefer that which is more stable, tertiary more stable than secondary and more stable than primary. So this is your stable product It's a major product because it's a primary. It's a primary and it is your secondary, CH secondary. So this is your chlorination of ethyl benzene, which giving two products, but the one product is preferable, and preferable product is that whose free radical is more stable. So next is, so all these are the substitution reactions in the presence of sunlight. Now next you can take nitration of alkane. Nitration of alkane is not possible at low temperature. It only possible at high temperature, and various products formed, that is your mixture of products formed. First of all, you take concentrated HNO3, concentrated HNO3 giving you 2, that is NO2 radical and OH radical. At high temperature when it breaks, it giving you HNO3, one NO2 radical, another is OH radical. So I'm taking one of the example. Let you take the example is propane. CH3, CH2, CH3. It's a propane, nitration concentrated HNO3 at a very high temperature. The products forms are, so I'm writing the products, nitropropane, mixture of, because at a high temperature bond cleavage takes place. So 1, 2, 3, it's a 1 nitropropane, it's a 1, 2, it's a nitroethane, it's your plus 1 carbon with nitromethane. So when you will do direct nitration of alkane, a mixture of products possible, even 2 nitropropane possible. So this is a nitration of alkane, concentrated nitric acid at a high temperature giving free radical, NO2 radical, NO2 radical gets substituted at various positions. Why the bond cleavage takes place? Because radical formation only takes place at high temperature, and at high temperature CC bond undergo cleavage, and number of products possible like 1 nitropropane, 2 nitropropane, and it is your nitroethane and nitromethane. So this your reaction is nitration of alkane. I have taken propane. Now write down next is sulfonation of alkane. Third is sulfonation. Sulfonation of alkane, it is your SO3H radical forming concentrated sulfuric acid SO3H. This is the radical form, SO3H plus OH radical. Now if you do sulfonation, that it is, I am taking example tertiary, it's a tertiary alkane plus concentrated sulfuric acid at a very high temperature. Write down high temperature, and the answer is Cr tertiary, and it is your SO3H. So it is your sulfonation of alkane. Now there is one more, fourth is, I am taking free radical substitution reactions in alkene. It was alkane, halogenation, nitration and sulfonation. Next is with alkene. If the question comes CH3, CH double bond CH2, it is the allylic carbon. If the reaction comes, for example, the reaction comes with bromine in the presence of sunlight, NBS. NBS is a N-bromosucciniamide. N-bromosucciniamide. Never reaction takes place addition, because the bond is a double bond. Always the addition actions takes place. But dear children, when the reaction comes in the presence of NBS, remember NBS is N-bromosucciniamide, the reaction is always substitution, and the substitution takes place at allylic and at benzylic. This is allylic, the answer is CH2Br, CH double bond will remain intact as such. So this is the substitution reaction even in alkene. So I am taking one more example. This is your cyclohexene. Cyclohexene double bond, next is again same, and bromine in the presence of same, that is your sunlight and even NBS presence. The reactions, substitutions takes place at allylic position. and allylic is this much. The answer is this, chlorine. So this is a free radical substitution reaction. Now we have completed substitution reactions, nucleophilic, which following SN1 and SN2 path. I have already uploaded the videos of nucleophilic substitution, electrophilic substitution and free radical substitution. We have completed thoroughly substitution reaction. Next time I am going to start the new type of chemical reaction. There are various type of chemical reactions: substitution, addition, elimination, rearrangement. One by one I am taking. So we have completed fully with substitution reactions. Now next lecture I will give you regarding addition reaction. Thank you.